In the previous video, we established some rules that we can use to help us predict whether ionic compounds are going to be soluble or insoluble, right? So whether they'll dissolve in water, meaning soluble, or whether they're going to remain a solid, meaning insoluble. Okay, so we saw that we have basically three priority groups. We have the first priority group, which is soluble. So any ionic compound that contains an ion from this group will always dissolve in water. We have a second priority group that is usually insoluble unless they're partnered up with something from the soluble group. And then our third priority group, which is normally soluble, but if one of these anions happen to be partnered up with a cation from group 2, from our insoluble group, then it will be insoluble. So let's go ahead and see how we can use these guidelines to help us predict the phase of ionic compounds in chemical reactions. Let's start off with a fairly simple reaction where we have the ionic compound silver nitrate, and silver nitrate is reacting with sodium chloride. Okay, so first things first. When we have two ionic compounds that are reacting together, we call this a double displacement reaction. Okay, so a double displacement reaction, what happens is the two cations swap places. Okay, so we're going to end up with the sodium partnered up with a nitrate. Okay, so one of our products is going to be a sodium nitrate, and our other product is going to be silver partnered up with the chloride. Okay, so double displacement, the two cations swap places. Now we can look at this and make sure that everything's balanced. And in this case, everything is. I have one nitrate, one sodium, one silver, one chloride, one chloride. So it's a balanced reaction. The last thing that we want to do, though, is to assign phases to each of our reactants and products. Okay, and to do that, we need to recognize that we can predict the phases of each compound based on our solubility rules. So silver nitrate, we see the key ion nitrate here, and we know that nitrate is always soluble, so that means this compound, silver nitrate, will dissolve in water, so this ionic compound will be aqueous. Same thing goes with sodium chloride. So sodium is a group 1A metal, so group 1A metals are always soluble, meaning this ionic compound will be aqueous. Sodium nitrate contains two ions that are always soluble, so it's going to be aqueous, right? So it has sodium and nitrate. Silver chloride, however, now has one of our key insoluble ions, and chloride is normally soluble, but remember, if it's partnered up with silver, it's going to be insoluble. So when we have an insoluble ionic compound, it does not dissolve in water, it remains a solid. So if we were to mix together these two solutions, one that contains silver nitrate and one that contains sodium chloride, we would actually see a solid forming, and that solid would be silver chloride. Let's try one more. So let's examine the reaction between lead acetate and let's go with potassium carbonate. Okay, so in this case, our two cations swap places, so potassium will replace lead and lead will replace potassium. So one of our products is going to be potassium partnered up with acetate. Each of these ions have a common stable +1 charge, so I have a potassium acetate. Okay, and the other ionic compound is a lead, which has a +2 charge, partnered up with carbonate, which also has a +2 charge. So I have lead, carbonate. Okay, so let's balance this. I see I have one lead. I have two acetates and only one acetate here, so I need to have coefficient of 2 out front. That gives me 2 potassium acetates. I have 2 potassiums, 1 carbonate, 1 carbonate. So now we're balanced. The final step is to assign phases based on our solubility rules. Acetate is always soluble. We see that in our list of group 1s. So lead acetate is soluble. Potassium is a group 1A. So this is always soluble. So this is aqueous. Potassium acetate, both of these are in our soluble group, so it's aqueous. And lead carbonate, we see lead and we see carbonate in our list of insolubles. So lead carbonate is insoluble, so it's a solid. So just like in the previous example, if we dump these two solutions together, we will see a solid forming, and that solid is lead carbonate. In the next video, we're going to take these two reactions, so make sure you've written them down and you have them in your notes. We're going to start with these two balanced ionic reactions, and we're going to see how we can break them down into a little bit simpler way of representing the true chemistry that's actually happening here. They'll be called our net ionic reactions.